Now that we have our universal formula for a circle, we are almost ready to move on to our next conic section, that of the ellipse. But before we get to that, we're going to review a couple things that we probably did last year in geometry. So this is just going to be a quick kind of refresher to make sure we're all on the same page. Excuse me. And it's going to be the distance and midpoint formula when we're dealing with lines in a coordinate plane. To start us off really easy, let's start with a really simple line in a coordinate plane. So I've graphed these 2 points, A and B. A is at 1, 2, and B is at 5, 2. So since they both have the same y coordinate, we can see that this is going to be a perfectly horizontal line. And for lines that are perfectly horizontal or vertical, it's super easy to find the distance, right? We can just kind of start here and go 1, 2, 3, 4. This is 4 units long. If it's 4 units long, that means the midpoint is going to be halfway in between the 2 points. So if it's 4 long, that means we just need to go over 2. Right? So 1, 2. And our midpoint will be at 3, 2. So very easy to define the distance and midpoint for a perfectly horizontal or vertical line. But what if it's not one of those easy cases? What if it's diagonal? Then things get a little bit more sophisticated. So let's take a couple of random points. -2 and 3. So -2, 3. I'm going to call this C at -2, 3. And our D is going to be 4, -5. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Alright, good. And actually, let's get another color up here. I'm going to join C and D. Alright, so our first question is, how long is this line? Alright, so the way to kind of approach this is rather clever, is to essentially use the Pythagorean theorem. But obviously we don't have a triangle just yet. But we can make a right triangle really easily. If we start at C at -2 and just drop straight down to -5, a little bit too far, and we go from +4 on the x. All right. So now we've made a right triangle where the line that we want is the hypotenuse, that red line. All right. So how tall is this right triangle? Well, on the y-axis, we started at +3 and we dropped all the way down to -5. Right. In this case, we're kind of looking more at the absolute value, so it's really just going to be these 3 units, and then this is 5 units long. So this whole thing is 8. All right, and then down here, we're starting at -2, going to 0, so that's going to be 2 units long, absolute value speaking. And then from 0 to +4, so this whole thing is 6. Good. So now it's pretty easy to find how long that diagonal is, right? We now have the lengths of our sides. So if you remember for Pythagorean theorem, a squared plus b squared is equal to c squared, where a and b are the legs of the right triangle, and c is the hypotenuse. So in this case, let's call a 8, b will be 6, 8 squared is 64, 6 squared is 36, 64 plus 36 is going to be 90, 100. Ooh, that's a nice, easy number. Excuse me. So if c squared is equal to 100, then square root both sides, and we get c is equal to 10. So we've just defined the length of, or the distance of our line. It is 10 units long. Fortunately, the numbers worked out really neatly in that case. I swear I picked those numbers randomly. All right, but let's see if we can try to universalize what we just did. Think about what the kind of the process that we went about. We added the y coordinates to get one of the legs, and we added the x coordinates to get the other leg, and then we squared them and then square rooted it. So let's see if we can kind of universalize that for just a second. All right. Want to get a little bit more bored there. So we could just add the x's, add the y's, and then square them. However, that's not always going to work because, as in this case, sometimes the coordinates are going to be positive or negative, and that's going to mess up our sums. So a way to kind of get around this is just to pick one point to be your first point and your other point to be your second one, and then just keep this ordering. Rather than finding the sum, we can find the sum in kind of a backwards way by taking the difference. So in this case, let's make C our first point. So we'll call this point 1, and D will be point 2. What we're going to do is take the difference of the x's. So we're going to take -2 minus, and then the x coordinate for the second point is 4, quantity squared. All right, and this is essentially going to get us our one of our legs, specifically this bottom leg down here, right? Because if we take the sum, this would get us, if we made it -2 plus 4, that would get us +2, and that is not the length of one of our sides. But by taking the difference, knowing that we're going to square it, it's like we want to get the negative version of the absolute value so that when we square it, everything kind of works out okay. Because -2 minus 4, that's -6, but it doesn't matter that it's negative because once it's squared, we're still going to get our 36 right here. All right, so we're going to do the same thing with the y's. So this is essentially our 36. All right. Remember, the Pythagorean is plus. So we're going to take our y's. So again, we're going to go to the y of our first, which is 3. We're going to subtract -5, quantity squared, right? And ultimately, this is going to be equal to c squared. But rather than writing c squared and then square rooting later, let's just make it, c, or rather d for distance, and then just go ahead and square root this whole thing. All right, so we're going to see that these numbers are going to work out just like they did right here. So d is equal to the square root. -2 minus 4, that's going to be -6. -6 squared is going to be 36. And then plus 3 minus -5, that's the same thing as add the opposite. So 3 plus 5, that's going to be 8. 8 squared is 64. And then we get everything that we got just before. Booyah. And our distance is 10 once again. So to kind of universalize what we just did here, here's the distance formula kind of distilled. We're going to take x1 minus x2 quantity squared plus y1 minus y2 quantity squared. It's time for me to go. All of that, take the square root, and that's going to be our distance. All right, cool. So, and just a reminder, if you're wondering, okay, well, what's x1 and what's x2? It doesn't matter. So long as this x1 and this y1 are the coordinates of one point, then you're fine, right? So it all matters about the ordering since we're dealing with differences, or rather subtraction. This -2 and 3 go together, and then this 4 and -5 go together. So just pick a point to be your 1. Take the x1, put it here, and the y in here. Whatever point you designate as your second point, the x and the y here, and then just kind of plug it into that formula, and it's pretty straightforward. For the midpoint, since I'm kind of out of time, we're just going to make real quick work of it. It's going to follow something kind of similar. Namely, we want to rig it so that it doesn't matter if the coordinates are positive or negative. It should work no matter what. And essentially what we're going to do is take the average of the x-coordinates and the average of the y-coordinates, right? So in this case, we know somewhere on this red line is the midpoint, right? Some point that is 5 units from C and 5 units from D. But since this isn't flat, I can't really measure out 5 units the way I would like. But there is an easy way to go about this. If I want to find the x-coordinate of the midpoint, I know, again, going back to our right triangle, I know that it's going to be on the midpoint, or it's going to be in line with the midpoint of this horizontal leg right here. Right? Okay, so that makes sense. So think of this as the total horizontal displacement. I know that the midpoint of the red line is going to be halfway across this horizontal displacement. Now, this horizontal line, super easy to find the distance and midpoint of it. It's 6 units long, which means half of that is going to be 3. So I can start here and count over 3 at 4. So I can go back 3, 1, 2, 3 to end up here at positive 1. Or I can start here at negative 2 and count up 3, 1, 2, 3. All right. So I know that the midpoint of the red line is going to be somewhere on this. All right. So it's looking like it's going to be right around here. Now for the vertical, anyways, so we know that the x-coordinate of this point here is going to be positive 1. All right. But now for the y-coordinate, we're going to do the same exact process. This whole vertical line represents the vertical displacement of our line. So just take half of that. This whole thing is 8 units long. So start here. You can count down 8. 1, 2, 3, 4. Here. Or you can start down here and count up 4. 1, 2, 3, 4. So the midpoint is going to have to be on this line. And we can see that we've kind of zeroed in on where we are. And this is at the y-coordinate of negative 1. Excuse me. All right. Excuse me. So hopefully that process made sense. So essentially what we did was find the sum of the x's, take half of it, and then apply it to one of the sides. So this whole bottom line was 6, so we're going to go 3 units from either endpoint. This whole vertical line was 8, we're going to go 4 units from either endpoint. A way to kind of universalize this, or sorry, rather, to kind of write down what we did verbally just now, we essentially did negative 2, which is the x-coordinate of C, plus 4, which is the x-coordinate of D, divided by 2. Oops, sorry, not that yet. Then for the y, we took 3, which is for the C, plus negative 5, divided by 2. Right, this is going to get us our midpoint. Negative 2 plus 4 is going to be positive 2. Positive 2 divided by 2 is going to get us our 1 for the x. So if that wasn't clear, this is going to be the x-coordinate for our midpoint. This is going to be our y-coordinate for our midpoint. 3 plus negative 5, that's going to get us negative 2 over 2. Negative 2, or sorry, 2 over 2 is going to be 1. Negative 2 over 2 is going to be negative 1. Right? And that's how we get our midpoint. So to universalize that, I'm just going to reuse this. Take the sum of your x's, divide by 2 to get the x-coordinate of your midpoint, and then likewise for the y-coordinates, y1 plus y2 all over 2. All right. Easy enough. So we have our distance formula, and we have our midpoint formula. All right, and I think that's sufficient for the evil of this video. All right.